What's up, guys? Today we are learning about solving equations containing radicals. It is the last lesson that I will be giving to you, so I hope that you have enjoyed having me as a teacher. I've definitely enjoyed having you guys as students. Um, you know, you were my youngest class when I started at Oak Hill, and now you're finishing it off after these 3 years. So, thanks for all the good memories, and I hope to see you guys in the future. When you visit Oak Hill, make sure you come and say hi to me. So we'll get started today. We're solving equations. It's really not too difficult. I've given you the steps up here at the top. You can read through them. The first goal is to isolate a radical by itself on one side of the equation. You square both sides and then you simplify. And then on these, you always have to check your solution because sometimes you get like false positives, is what I call them. So we always have to check our answer back into the original equation. So if we look at number one, the radical is already isolated. So notice the square root is by itself on one side of the equation. It's by itself on the left side of the equation. So that's the goal. Once you have that, what you do is you square both sides of the equation. If you square one side of the equation, you have to square the second side of the equation. So remember, squares and square roots are opposites. They would cancel each other out, leaving you with x plus 3 equals 5 squared, which is 25. So you see it's very easy to solve this. Subtract 3 from both sides, and x would be 22. Very simple stuff today. So all we have to do is check our solution back into the original equation. So 22 plus 3 is 25. The square root of 25 is 5. It was supposed to be 5, so we've checked this one. It worked. Let's look at number 2. Number 2, the radical is not isolated. Notice there are other things on the left side of the equation with the radical. So our first step is to isolate the radical by subtracting 6 from both sides of the equation. That gives us the square root of x equals negative 2. Okay, now that we have that radical isolated, we're ready to square both sides of the equation. So we square the left side, we square the right side. The square and the square root are opposites. They cancel each other out. So x would equal, what's negative 2 squared? Remember, that means negative 2 times negative 2. So that would be a positive 4. Okay, now we got to go back to our original equation and plug it in. So what's the square root of 4? That would be 2. 2 plus 6 is 8. 8 does not equal 4, so this one does not work. There is no real solution to that equation. So that happens sometimes. If you want to pause the video here and try 3, that would be great. It's a lot like number 1. All right, let's see how you did. The radical was already isolated, so you should have squared both sides of the equation. That would give you x minus 5, because these cancel each other out, equals 4. Add 5 to both sides of the equation, you get 9. Plug it into the original. What's 9 minus 5? That's 4. What's the square root of 4? It's 2. That was what it was supposed to be, so that equation checked out. Okay, number 4, we have radicals on both sides of the equation. They're both already isolated, so this is going to work out really nicely. You just go ahead and square both sides. The square and the square root are opposites. They cancel each other out, so we're left with x equals 5x minus 2. So we have variables on both sides of the equation. We want to get all variables to one side of the equation. We would do that quickly on this one by subtracting 5x from both sides. 1x minus 5x is negative 4x. So I've got negative 4x equals negative 2. The last thing to get that x by itself, divide by negative 4. Now look at this, it's not negative 4 divided by 2, it's negative 2 divided by negative 4. So that is positive, and then 2 over 4 reduces to 1/2. So x is 1/2 in this case. Okay, so this one, we got to check it. So we have back into the original equation. On the left side, we have the square root of 1/2. Now, I don't know what the square root of 1/2 is, but if the right side comes out to be the square root of 1/2, we know it's the same thing, right? So I'm not even going to figure out what the decimal equivalence of the square root of 1/2 is. On the right side, let's see, 5 times x, which is 1/2. 5 times 1/2 is 5/2 minus 2. Remember, 2 is the same as 4 over 2. Is 5 over 2 minus 4 over 2 1 over 2? Yeah, this one checks. Okay. Number 5, let's look at it. That radical is on the left side of the equation all by itself, so we're ready to square both sides. The square and the square root cancel each other out, so I'm left with the 4y squared plus 5y minus 15 that's under the radical. On the right side, 2y squared means 2y times 2y. So 2 times 2 is 4, y times y is y squared. So 2y squared is 4y squared. And that's really convenient because when we get all of our squares to one side of the equation, we would subtract 4y squared and they would cancel both of them out. So that's going to give us 5y minus 15 equals over here 0. So we just have to add 15 to both sides of the equation, and if 5y equals 15, we all know that y would be 3. Okay, now let's go back and plug it in. All right, you're going to have to follow along here. I'm going to do some mental math. 3 squared is 9. 9 times 4 is 36. I'll write that down. 5 times 3 is 15. And then minus 15. So those would cancel each other out. So I have the square root of 36, which is 6, right? On the right side, 2 times 3 is 6. Does 6 equal 6? Yes, it does. This answer checked. Okay. Now let's look at 6. 6 is a tougher type of problem because of what happens. Notice this radical is not on the left side of the equation by itself, so our first step is to add x to both sides of the equation. So I have the square root of x plus 3 equals, if I put that in the correct order, x minus 3. Okay. So now that radical is isolated, we square both sides. The square and the square root cancel on the left side. That's nice and easy, x plus 3. On the right side, we have to remember what squaring means. When you square a binomial like this, a 2-term or a 3-term or however many, more than one term, when you square it, it means times itself. So what we really have is x minus 3 times x minus 3, and we have to distribute that, do the FOILing. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x, and then negative 3 times negative 3 is positive 9. If you put those middle terms together, we would have x plus 3 equals x squared minus 6x plus 9. Okay, so this leads us to a problem that has a square in it. So if you have a square, remember the process is to set the equation equal to 0. We would do that, and we want our squared term to be positive. We would do that by subtracting x from both sides, and at the same time subtracting 3 from both sides. So I would have x squared, that's a negative 7x, because remember there's a 1 in front of there, plus 6, and then instead of equals 0 on the left side, which is what I have, I like it to be on the right side, so equals 0 over there. So remember, this is a trinomial that needs to be factored. Since there's no number in front, we don't have to do the magic number. We can go straight into the 2 sets of parentheses. Okay, so if my third sign is positive, remember that means I adopt the sign of the second for both. So it's going to be x minus something and x minus something else. If it were a negative number, that last term was negative, remember that would be 1 positive and 1 negative. So if the third sign is positive, use the sign of the second for both. If the third sign is negative, 1 sign of each. Okay, now we look at 6. What are the factors of 6? They are 1 times 6 and 2 times 3, right? Those are the only ways you can multiply to 6. Which of these add to make 7? 1 and 6. We drop them in. Now that it's completely factored, you take each factor and individually set it equal to 0. Look at that, factoring always coming back. You gotta love it. So solve that, and x would equal positive 1, and x would equal positive 6. Now remember, we do have to check our solution, so we got to go back to the very original and plug it in. So that's here. We got to do them each individually. So first we'll check 1. What's 1 plus 3? 4. What's the square root of 4? 2. What's 2 minus 1? 2 minus 1 is 1. What's it supposed to be? Negative 3. This one did not work. Let's try 6. What's 6 plus 3? 9. What's the square root of 9? 3. What's 3 minus 6? 3 minus 6 is negative 3. What's it supposed to be? Negative 3. This one checked. So we got one solution out of the 2 possible solutions. So x is 6. All right, on the back, just one more example. So here we see we have a radical isolated on the left. It is not isolated on the right. That's okay. The goal is to just get one of them isolated, which we do have. So we are ready to square both sides. On the left side, it's just a single radical, so it can cancel each other out, leaving you with x minus 4. On the right side, we have that binomial, so it has to be distributed out. Okay, so what's the square root of x times the square root of x when we multiply this? Square root of x times the square root of x is x. The square root of x times negative 2 is negative 2 square roots of x. Negative 2 times the square root of x again is negative 2 square roots of x. And then negative 2 times negative 2 is positive 4. If we put those middle terms together, I would have x minus 4 equals x. Negative 2 minus 2 more is negative 4 square roots of x, and then plus 4. Okay. Now I want to get this radical isolated. So my answer, or my problem still has a radical in it, so I need to get this radical by itself. The first thing you would do is subtract x and subtract 4. So it looks like x minus x, those are going to cancel out too. I would have negative 8 equals negative 4 square roots of x. That radical is almost isolated. The only thing left to get it by itself is to divide by negative 4. Those cancel on the right. What's negative 8 divided by negative 4? That would be a positive 2. 2 equals the square root of x. So now this radical is isolated, and now we have to square both sides. Nice and easy one this time. Square and square root cancel each other out, and looks like x equals 4. Okay, let's go back to the original and plug in 4 and see if it works. 4 minus 4 is 0. The square root of 0 is 0. Over here, the square root of 4 is 2, and 2 minus 2 is also 0. Those match. So this solution checked. It's probably better to write x equals 4, but that's okay. So I would pause the video here. Try number 8. It's exactly like 7, and we'll see if you can get the same solution. So pause it now. We'll see how you do. All right, you should have squared both sides. On the right side, that means the square root of x minus 4 times the square root of x minus 4. That one has to be FOILed. That was the left side. On the right side, the square and the square root cancel, giving you x minus 16. That one's nice and easy. Okay, distribute over here. The square root of x times the square root of x is x. The square root of x times negative 4 is negative 4 square roots of x. Same thing in the middle there. And then negative 4 times negative 4 is positive 16. It still equals x minus 16. All right. Let's combine those two middle terms there to get x minus 8 square roots of x plus 16 equals x minus 16. Okay, now since we still have a radical in our problem, we need to isolate that radical. We would start by subtracting x from both sides and subtracting 16 from both sides. So I would have negative 8 square roots of x equals, those cancel also, negative 32. We're almost there. Next, to get rid of that negative 8, to get that radical by itself, we would divide by negative 8. Looks like the square root of x equals a positive 4. From there, you should square both sides. Square and square root cancel, giving you x equals 16. Now we just have to check your solution. Let's see if you got it. Square root of 16 is 4. 4 minus 4 is 0. That one's 0. 16 minus 16 is 0. Square root of 0 is still 0. So this one did check, just like the last one, and 16 was the solution. So again, you guys, it's been great having you as students. You really are a fun class to have. I really enjoy you guys. So hopefully we'll see you soon. Have a great summer if I don't talk to you on Thursday. Bye now.